So, welcome back. After having seen the property changes that happens in the subcooled or compressed liquid region, when you go on compressing the subcooled liquid to higher and higher pressures, we had seen that what is this percentage change that happens in these properties. So, on this slide I can again show you the same table where we saw that with the compression of the liquid, subcooled liquid from its Psat value, which is 0.15 MPa, to going to a very high pressure, in fact above the critical pressure of water, we saw that the value of V changes by only 1.21% compared to its Vf value, or Vf, that is the value at the saturation pressure of water, alright. Corresponding to its saturation value, if you see, these changes are with respect to the Vf value which lies on the two phase region or LV line. So, if I compare these property changes at higher and higher pressure with Vf, Uf and Sf, these are just close to 1%, just above 1% I should say. As far as H is concerned, the variation is little more than other properties. So, what do I conclude from here? It is a very important conclusion that can be drawn from these figures, from these numbers. So, we can see that if I just concentrate on the first column or the second column, the property column, which is specific volume, we can say that the specific volume at 25 MPa can be approximately be equal to specific volume at 5 MPa, or for that matter 10, 20 MPas, and also all of these are equal to Vf at 0.15. That means specific volume at 0.15 MPa or on the LV line, on the two phase curve, alright. So, these changes whatever are happening, because they are happening in the fifth decimal place or the changes are just above 1%, we possibly can neglect those changes. Even after compressing from 0.15 to 25 MPa, these changes are approximately negligible. If I assume this, we can say approximately V25 is equal to V5 is equal to Vf 0.15. We can conclude one more thing, that specific volume, which is a function of pressure and temperature, I can say that specific volume in this region, subcooled or compressed liquid region, is not a function of pressure. That is what we have seen here. Even if I went on compressing, I could not see a effect, a significant effect because of this compression process. That means P parameter here possibly is missing, and I will say in this region, in the subcooled or compressed liquid region, specific volume does not depend on pressure, it depends only on temperature. When I say it depends only on temperature, I have not shown this, but you can verify it using the steam table, alright. Similarly now, if I look at other properties, if I look at thermal energy, you can see this percentage change hardly again matters so much, and again can conclude that UPT is approximately equal to UFT. So, at higher and higher pressure, these properties is the same as what it was on the saturation pressure line, on the LV line, alright. So, I will say that again it is independent of pressure, it does not depend so much on the pressure. Similarly, I can see for the S also, or for the entropy also, because this variation also is negligible, I say SPT in the subcooled or compressed liquid region does not depend on pressure. It is approximately equal to SFT, that means P is not there at all. What do I say from this? I will say that there is a weak dependence on pressure in this region. The properties V, U and S have weak dependence on pressure. And why is this? Why am I making such a statement? Because if you remember, right in the first lecture, we had tried to compress liquid, alright. If you remember the compressibility of liquid, we had said that liquid is incompressible. So, even if I compress liquid, we had said that it does not get compressed so much. The density changes, the volume changes were hardly anything then as compared to that for the gas. Gas is compressible, but liquid we had concluded can be considered as incompressible. So, this is the reason the weak dependence on pressure is basically we say that liquid is incompressible. So, in this region of subcooled or compressed liquid, because we know that liquid is incompressible, Even if we go on compressing liquid, it makes hardly any changes in the properties of this subcooled liquid or a compressed liquid at higher and higher pressures. And that is why we say that Vpt is equal to Vft, Upt is equal to Uft and Spt is equal to Sft. P is missing from these values because in this region of subcooled liquid, this fluid is incompressible, alright. Pressure will not play a significant role in this case. Now I am talking only about 3 properties, while the 4th property was enthalpy. And enthalpy I can write HPT, enthalpy as you know is H is equal to U plus PV, enthalpy is equal to U plus PV. So if I write dependence of enthalpy, so H depends on P and T generally is equal to UPT plus P and VPT as we know. But in this region we have already concluded that HPT is equal to UPT is UFT. So if I go on writing those values, UPT is equal to UFT and VPT is equal to VFT. So because I know that the dependence in this region on pressure is negligible, I can write VPT as VFT and UPT as UFT. So if I see overall enthalpy dependence in the subcooled region, I will be getting governed by this equation now, UFT plus P into VFT. What do you mean by this? What do you see from this? If I go back to the table again, I see that the enthalpy dependence on the pressure, if not very significant, it is still there. The changes had been of the order of 3 to 4% as against 1 to 1.5% in other properties. It does show that as you go on compressing this liquid further, there is some dependence on the pressure. And why does it show? It shows because of this presence of P here. If I come back to the equation, you can see that this is the pressure which plays an important role, because even if UPT is equal to UFT and VPT is equal to VFT, there is a P term that appears there which directly relates HPT or the enthalpy to the pressure term. So if I go on increasing the pressure will show up on enthalpy because of this formulation, alright. In the other case there is a weak dependence, but there is the pressure dependence in this case, and that is why you see in a table that for enthalpy I cannot assume that HPT is equal to HFT. I cannot do this assumption, while I can do the same for V, U and S, but not for H because of the presence of this P term here in this particular equation for enthalpy. So approximation I can do with volume, with respect to volume, thermal energy, entropy for subcooled liquid may be taken same as Psat itself. If I want to find out the properties or the values of these properties at higher and higher pressure, I need not go to higher and higher pressures, I can do the same thing at Psat value only, knowing that higher and higher pressure, because this subcooled liquid is incompressible, the properties will not change so much, and therefore properties like V, U and S can be taken directly at Psat itself. Yeah, this is the reason VUS at PT is equal to VF, UF, SF at Psat T, alright. However, enthalpy has to be calculated at the particular point as it is pressure dependent, which is what we have seen, that HPT cannot be approximated as HF Psat T, which is what we could do because of the basic formulation of the enthalpy itself. As we have done this formulation, I have shown this formulation earlier, alright. So properties can be taken VUS at Psat, but not the enthalpy. Enthalpy can be directly computed from this formulation. Why did I do all these things? It was first of all to show you that such an approximation holds good for V, U and S, but importantly there are lot many steam tables which do not give all the properties. The one which we are giving you, it gives the properties at higher and higher pressures only, no problems. You can go into the details and find out all the properties at higher and higher pressures. There are some steam tables which do not give the complete data for subcooled or compressed liquid regions. They may give you properties at 0.15 for example, and the next property may appear at 20 MPa state away or 15 MPa state away. It is expected that you find out the value at 0.15 MPa or Psat, and you can take the same values for 1 MPa, 2 MPa, 3 MPa with the approximation that subcooled liquid is incompressible, alright. In our table, as far as the table that we have given, that is not a problem because you got the values at 0.15, 0.16, 0.17, 0.2, etc., where all these values can directly be taken from the steam tables. But there are some steam tables which do not give the complete data for subcooled or compressed liquid. In such cases, properties at higher pressures may be approximated using PSAT values. So, I need to take only the values at PSAT, and assuming that the liquid is incompressible, I use the same values for further calculations. I hope you are clear with this. This is an approximation which we may not use, but I expect that all the students of thermodynamics should know about this approximation, just because of the fact that subcooled liquid is incompressible. Thank you very much.